Assalamu alaikum students. Unit number 7, Introduction to Trigonometry, and exercise 7.3 we were solving, and in the last lesson I have explained you about trigonometric ratios and the fourth quadrant system. The theory I written on the page in the last lesson has been explained on your book as well. If you want to study it from the page number, the page number 156. From page number 155 it is the quadrant and quadrantal angles. I can zoom in for you. The x-axis and y-axis divide the plane in 4 regions. As you know, x-axis and y-axis divide a plane into 4 regions called quadrants. When they intersect each other at right angle, the point of intersection is called origin and is denoted by O. You are already familiar with it. Angles between 0 and 90 are in the first quadrant. The angle between 0 and 90 is the first quadrant, and 90 to 180 are the second quadrant. 180 to 270 is the third quadrant, and 270 to 360 is the fourth quadrant. An angle in standard position is said to lie in a quadrant if its terminal side lies in that quadrant. Terminal side means the angle theta, alpha, beta, gamma. They are called the terminal side of the given trigonometric ratios. Then quadrantal angles, 90, 180, 270, 360 are quadrantal angles. And next, the introduction of trigonometric ratios is started from this topic right here. Trigonometric ratios and their reciprocal with the help of unit circle. The same I explained you earlier. The only difference is the quadrantal are 1, -1 and 1, -1 here. It means the values if the trigonometric ratios are lies between 1 and -1, not greater than 1 and not less than -1 values of trigonometrics exist. Here in this example you can see a point circle is given, a point circle where if you draw perpendicular P to E, you have 3 sides. He has explained it to you here. Sine of theta equal perpendicular over hypotenuse y over 1, cos theta equal base over hypotenuse x over 1. You can see cos theta and sine theta are the x coordinate and y coordinate of the point P. You have already studied it in the resolution of forces on the unit circle. The x equal cos theta and y equal sin theta are called trigonometric functions. The remaining trigonometric function tangent, cotangent, secant and cosecant will be denoted by tan of theta, cot of theta, and the last line secant theta, cosecant theta for any real angle theta. On the next page clearly you can see this box where trigonometric ratios with their reciprocal are written. Sine, its reciprocal is cosecant. Cosecant is reciprocal is sine. Similarly, cos is the reciprocal of secant and secant is the reciprocal of cos. Tangent is the reciprocal of cotangent and cotangent is reciprocal of tangent. Example number 2 you can follow for better understanding. And then the values of the trigonometric ratios are also mentioned here. In case of the values of trigonometric ratios for 45 degree, 30 degree and 60 degree, these values are also important. We must know about the values of trigonometric ratios at different angles. So if you see, consider a triangle ABC with measurement angle C is equal to 90. The side opposite to the vertex A is small a. The side opposite to small vertex is C, and capital B in front of capital B will have side B. Okay, when measurement angle is 45, if one angle is 90, other one is 45, then third one will be 45. In case of radian it will be pi over 4. Since the sum of angle is 180, so measurement angle B is 180. As values of trigonometric function depends on the size of the angle, not only on the size of triangle. For convenience, take A equal 1, B equal 1. And using Pythagoras theorem, the hypotenuse will be hypotenuse square equal base square plus perpendicular square. It will be square root 2. And now Sin theta, you know, perpendicular over hypotenuse. Sin theta will be, sin 45 will be 1 over square root 2. Cos theta, you know, base over hypotenuse. Cos equal 1 over square root 2. And tangent theta, you know, it is perpendicular over base, 1 over 1 equal 1. So you can check that sin 45 1 over square root 2, it means its reciprocal will be square root 2 over 1. Will not write 1 as mandatory. Cos 45 is 1 over square root 2, it means cosecant is square root 2. Tangent 45 is 1 and cotangent 45 is also 1. Then in another case, after doing the same, when A, B, C, the sides of the triangle are 2, 2, then the values of the trigonometric ratios is sin 630 1 by 2, cos 30 square root 3 by 2, tangent 30 1 over square root 3, cosecant 30 is reciprocal of sin 2, cos 30 2 over square root 3, tangent 30 square root of 3. Similarly, the values at the 60 degree are as below. Sin 60 square root 3 by 2, its reciprocal will be cosecant 60, it is 2 over square root of 3. Cos 60 is 1 over 2 and secant 60 is 2, tangent 60 square root 3 and cotangent 60 is 1 by square root of 3. And next, in the whole theory, he has explained you about 4 quadrant system, where all positive, sine and its reciprocal positive, tangent and its reciprocal positive while other are negative, cosine and secant are positive while other negative. In the detail, in the first, you can see greater than 0 mean sine, cos, tangent, cotangent, secant, cosecant all positive. In the second, sine and cosecant are only positive while cos, secant, tangent, cotangent, they are less than 0 mean negative. In the third quadrant, tangent and cotangent are positive while other are negative. Fourth, cos and secant are positive while other are negative. I hope you understand very well about this now. Further, if you face any difficulty, you can see the theory. And now let's move on and try and solve question number 8. More theories here. Different angles at 0 degree, the angles of trigonometric ratios at 0 degree, at 90 degree, at 180 degree and 270 degree. So lots of discussion of this trigonometric ratio is in FSC math, first year math and second year as well. And this is the very basics. Then the angle at 360 degree. Where the angle are in 0, 1 and -1, you can find it from the calculator as well. Sin 360, check the answer 0, 1 and any number, and when the 0 is the denominator of any number, the number will be undefined. It will be maths error on your calculator. So I used to calculate the values of sine of trigonometric ratios at 360, 270 and 180 and 90 on the calculator, and even 0 as well. You can find these values on calculator because their answer lies either 1, -1 or 0 or undefined. They are the only expected answer when you calculate the values of trigonometric ratios at 0, 90, 180, 270 and 360. Question number 8, the statement is, if tangent theta equal 4 by 3, tangent theta, the value of tangent theta is given 4 by 3, sine is negative, tangent is positive, sine is negative, find the value of the other trigonometric function at theta. I write the statement of question number 8. The statement is, if tangent theta equal 4 by 3 and sine theta is negative, then find the value of the other trigonometric function. Solution, how we'll solve them? Since it is given as tangent theta is equal 4 over 3 and sine is negative is the required condition, then what is the possibility? We know that 4 quadrant system, we want to find where the theta actually lies. It depends on the condition that is given, because theta is still unknown angle. He has given the condition to us. Tangent theta equal 4 by 3. Tangent is positive. Tangent is positive in the first quadrant and third quadrant. Okay, so sine is negative. Sine is negative in fourth quadrant and third quadrant. In the second, sine is positive. So the only possibility of tangent positive and sine negative is the quadrant number 3, because in the fourth quadrant tangent is also negative. So the suitable quadrant for tangent 4/3 and sine less than 0 is the quadrant number 3. It means for tangent 4 by 3, we know that the x-axis we have positive terminal here, and positive 1, 2, 3, it will lie in first quadrant. So instead we will, if we want to come here in fourth quadrant, then we must have to take 4 and 3 negative, because negative of x are here, x prime 1, 2, 3, 4, and negative of 3 are on the prime of y, -1, -2, and -3. So the point for -4, -3, it means 4/3 lies somewhere here. Now we join these dots and find that tangent 4/3 triangle here, tangent 4/3 from origin will take that position. Here is the right angle, it is -4, and this one is -3. It means we just need to find hypotenuse, and when we find the hypotenuse, we will be able to find the other trigonometric ratios. See, tangent theta, it is given that tangent theta is 4 by 3, but to be in the third quadrant, we take x as distance -1 and y distance as +1. Tangent theta equal -4 by 3, and you know that tangent is a reciprocal of cotangent theta. If tangent theta equal -4 by 3, then cotangent will be -3 by 4. Now for the rest, using quadratic formula, using Pythagoras theorem, in fact, Pythagoras theorem, hypotenuse square equal base square plus perpendicular square. Now hypotenuse is the unknown side, base is -3 whole square, and perpendicular is -4 whole square. 3 square is 9, -4 square is 16, and taking the square root of the expression, can you see it? Okay, 19 plus 16 is square root 25. So hypotenuse is 5. Now base is -3, perpendicular is -4, hypotenuse is 5. We will easily find the other trigonometric ratios as sine of theta. You know that sine theta is equal perpendicular over hypotenuse. It will be -4/5. Similarly, its reciprocal cosecant theta will be equal to -5 by 4. And two ratios are left. They are cos theta. Cos theta, you know, it is equal to base over hypotenuse, -3/5. And its reciprocal secant theta will be -5 by 3. So this is the way to find the unknown trigonometric ratios when one ratio and the condition on it is given. You will simply find the tangent value, and as tangent not sign is negative in the third quadrant and tangent is positive there, so instead taking tangent as 4 over 3, we take the value -4 and -3, so we'll take it in the third quadrant. After this, taking it in the third quadrant, we will find the unknown side, that is hypotenuse, using the same formula, Pythagoras theorem, you are already know, and at the end find the result. Now -4 and -3, you have find the values. Tangent is given 4 over 3, but we have taken it as -4 and -3 for this section. Now next we have to find the values is tangent theta will again 4 over 3, it is positive. Tangent is perpendicular over base -4 over -3, so tangent theta equal 4 by 3, and its reciprocal cotangent theta will be 3 by 4. So we will do the question number 9 very much similar to this in the next lesson. Then you will be understand it very well. At the moment I know you face it difficult because it is a very new kind of question for you, but once we start solving such problems, it will be easy for us. And the one problem is also the ALP has very reduced number of questions. They are on the book, we have 7, 8, 9, 10, 11, but in ALP we'll just deal with 2. So students doing more questions were able to understand the concept, but doing a few questions it will be difficult for them. I hope you will understand by doing the practice again and again in question 9 in the next lesson, inshallah. Thank you so much.